Hello, welcome to AARLCC's Summer Youth Programs. In our youth programs this year, we decided we're going to help some of our students who had difficulties with getting through math during this pandemic time, and when many people, some got their work done because they had the resources and ability, others didn't get it done because they did not have the resources and in some cases the abilities. So here at AARLCC, we decided during our youth summer programs, we're going to put out these virtual tutorials. The tutorials in this case are in mathematics, and the area of math that I'm going to focus on are pre-algebra and algebra. Now these are areas that will be most suited for my 6th graders, 7th graders, 8th graders, and 9th graders. Some of my 10th graders that are on the remedial side of math may need to come into this as well so you can get up to speed. We're going to do some basic stuff, but we're going to start basically with numbers and what numbers are, and we're going to work our way up into algebra. Now, I've prepared about 12 of these modules, which would take the typical pre-algebra and algebra students. If you're in pre-algebra, those 12 modules will take you through probably 75% of pre-algebra, if not more. If you're an algebra student, this should take you somewhere in the 50 to 60% area of what algebra itself is. Now, what we decided to start with is the basic stuff. To classify numbers. All numbers fall into this category. They call them natural numbers, but we want to kind of keep it simple for our pre-algebra students. Numbers can be classified into the following. One is called integers. The second is called whole numbers. Next, we have something called rational numbers. We'll start shortening up now. Then we get into irrational numbers. And then there is this weird animal called, at the end of the day, they call them imaginary numbers. Imaginary numbers we're not going to talk very much about up front because that's more into very late algebra, into algebra 2, that we start to talk about imaginary numbers. Irrational numbers you may see more about, but we are mostly focused on integers, whole numbers, and rational numbers. So we're going to begin with explaining integers. Integers are all numbers. They are natural numbers that include negative numbers, 0, and positive numbers. So here they are. Integers would be -5, 0, 4, 12, and so on. So a negative number is an integer, 0 is an integer, 1, 2, 3, 4, 5, 6, 100,000, these are integers. The next type of numbers are called whole numbers. Think of whole numbers as some item that I can take and I can either tear it or break it apart into multiple pieces. If I take a sheet of paper, that's a whole sheet of paper, I can tear it into 2 pieces, I can tear it into 3 pieces or 10 pieces as the case may be. So whole numbers will be a 1, 2, 5, 100, and so on. Any positive integer falls into whole numbers. The next type of number is called a rational number. A rational number simply means I can fall somewhere between two integers, or I can fall between two whole numbers. These are gaps between numbers that we need to account for in our number system and number classification. So, rational numbers can include the number 4. Rational numbers can also include 1/2. 1/2 falls between 0 and 1, so we can end up with 1/2. That is a rational number. Negative 2/3. That is a rational number. 5 is a rational number. So please look at this and be sure we understand rational numbers to be anything that is a whole number or an integer or anything that falls between those numbers, such as another example would be 3.5. That is also a rational number. The next two types of numbers we're not going to spend much time with right now because it's not part of what we're doing at this point. An irrational number is simply a number that cannot be resolved. The best example I can give you of an irrational number is pi. We know pi as 3.14. But if you were to take a calculator, a scientific calculator, and press the button pi on it, you'll see a number that runs all the way through the face of the display of that calculator, and it continues to go on, and it never ends. That's because pi is an example of an irrational number. And then the final type of number that we have in our classification of numbers are called imaginary numbers. Now, imaginary numbers are very difficult to explain to someone who is not working on the coordinate plane and trying to do something like solving a quadratic function that includes imaginary solutions. This is difficult to explain, especially for some of our 6th grade and 7th grade kiddos, but we'll talk about that later on, and just don't worry too much about it. But imaginary numbers are numbers that have some aspect of it that cannot be resolved at all. So if you take a number that cannot be resolved, in the math world, they have figured out ways to take those numbers, break them apart, and break them apart into a part that is real and a part that is not real, called an imaginary number. So if I want to give you an example of an imaginary number would be 3i. This is going to take us into negative numbers, and like I said, I don't want to explain too much of this right now, but generally speaking, we end up with an imaginary number whenever we end up with something called the square root of a negative number. Anytime we have the square root of a negative number, we are going to have some part of that that's going to be real, some part that is not real, called an imaginary number. Okay, so with these two here, I want you guys to not spend too much time worrying about that, because it's going to throw you off and you're going to start thinking, man, algebra is too hard. I can't get into that stuff. Nope, we're going to focus on integers, whole numbers, and rational numbers in our parts of thinking. Now, the next thing we're going to talk about is negative numbers. Now, negative numbers are slightly different in some people's minds, but they're really not all that different. Negative numbers simply mean I have this thing called a number line. This number line has a 0 somewhere in the middle, and going up, I have a 1, a 2, a 3, a 4, a 5, and so forth and so on. On the next side of positive numbers, or the next side of 0, I have a -1, a -2, -3, -4, and so forth and so on. Now, this is not exactly something that is new to anyone who is in algebra. If you're in algebra, this is something that you ought to already know from your 5th grade, 4th grade, and your 3rd grade math. And by the time you are in 6th grade, you should already know what a negative number is. For example, if I want to ask you to solve this for me, what is -7 plus 4? What is -7 plus 4 equal to? I will expect you to start with -7 and add on 4 to -7, so you'll have -7, -6, -5, -4, -3. So the answer to -7 plus 4 would be -3. Now I'm going to stop and tell you one more thing at this point. Whenever you come to an answer, you've worked out a problem and you've come to an answer, I expect you, or your math teacher expects you, to box or circle your final answer. So I'd like everybody to remember that if for some reason you happen to wind up in Mr. Caton's math class, you give me a final answer to a math problem, and it does not have a circle or a square around it, a box or a circle around it, you can expect to lose at least a quarter of your grade for that, because I am very strict about that. If you're going to get through my math class, you're going to move on to your next math teacher having that burned into your heads that you must circle or box your final answer. Now we're going to come back in a couple of minutes and we'll start up looking at expressions in algebra and pre-algebra, and we'll start to use integers, whole numbers, and rational numbers, as well as negative numbers. In some form, we'll be using that to create these things and to solve and to evaluate these things we call algebraic expressions. And I'll see you in a bit for that.